Off you go.
Do you want that one? Yeah. A plus BI, and we're going to call this one C plus DI.
Group work was an element which featured in many of the activities for further mathematics which these students helped us explore.
If you were to just times them together normally,
some people might say
you'd get 4 and then 15. And then...
This provided an opportunity for students and teachers to think about the benefits of group work in further mathematics and what makes it effective.
My own experience of group work versus teacher standing at the front is that the people that need to do the learning and make the mental connections are the students. So do you want to share what you've done in your pairs? If I'm standing at the front all of the time, then that's me covering the course and the syllabus, not the students. And there's the adage, isn't there, that it should be the students who are the people who are working hardest in a class. And if the teacher is at the front, just giving forth for an hour, the students aren't actually working very hard.
So if you flip this data around in front of it, you can then times it by 3, 1, 0.
The students here, sharing their findings, have been working on tasks which were designed in this case to support exploration. At other times, the teachers would facilitate different tasks for different purposes. For instance, here, a card matching activity designed to help make new connections, identifying patterns and possible generalizations.
So it's the one with the...
Here, another task, this time to help consolidate and clarify understanding. Students were to classify complex numbers using the Venn diagram. Like most tasks, it would encourage challenge and could, through the ensuing discussion, help resolve misconceptions.
Because if we want it to be imaginary
there's got to be no...
those two have got to be the same as that one.
Yeah.
This task invites students to order complex numbers. Its design makes it useful as part of a plenary. To agree an order, students would need to articulate their reasoning, and this is an opportunity to help them develop the use of mathematical terminology.
Doesn't exist.
Well, it does. It's straight. Is it straight up?
Yeah, asymptote.
Yeah.
During the cards talk, there was sort of a whole group discussion. Having 4 or 5 people in that conversation sort of allowed it to go in a lot of different directions.
And then that's in order of modulus.
It sort of focused on the modulus initially and how they might order it with the modulus, and then they focused on the argument.
So you could order them by the size of the imaginary part.
Component.
So that's got the smallest.
Yeah, then there's this one.
So
That's
it's 0.
no imaginary component.
And you've got,
And you've got
1.
Then 2.
And so it allows lots of different ways of students to view things. And I think having that sort of openness towards other students and allowing them to take on board their maths really does stretch them in different directions that they might not stretch themselves in necessarily.
Do you then make a list of one with the product of that times its complex conjugate, and the same with these?
So you're thinking about what numbers you need in different places to give you particular types of x and y's under rotations.
For teachers, it was an opportunity to think about planning the use of these tasks within a teaching sequence, how to intervene, and what they might learn when listening to students in discussion.
You two, could you tell me what you're doing there? One of the activities was the matching activity with the matrix cards, and whereas I was expecting what the students are going to do here is they're going to try transforming different points and seeing where they end up, and therefore working out what that transformation does. Whereas there was a pair of students who decided to do it in reverse.
Taken the point that it was originally.
Yeah.
And the matrices that we don't know what it's been times by, we've called A, B, C, D.
Okay.
And then that's got to equal the point that it's now turned into.
So that point there
image.
on the object has ended up there on the
Which is
image.
1 minus 2.
Yeah.
And then we're making equations from each point.
Okay, so 2a add b has to be 1.
Yeah. And then
2c
2c
add
plus
d.
d has to be minus 2. And
Right.
then we're going to take the points 0, 0 and the other 2 and put them into equations.
Right. And then effectively what they were doing was finding an inverse matrix by solving simultaneous equations, but that's what they were coming at it from a completely different angle. That was really encouraging. You've got 4 unknowns, haven't you? How many equations have you got so far?
2.
2.
We can make 4.
I mean, you can make 4 by using the other point.
If you had an argand diagram, and then it's the angle from here that it is.
You can work that out by the length too, between the triangle that can be made.
Asking another student, well, what's the argument? Again, having that student explain that really sort of confirmed that student's knowledge, but also enabled another student to learn. There's nothing wrong at all with allowing students to try and take their knowledge and direct it to someone else.
It was more helpful than when you do it individually on your own, because you get the two sides of what you're doing. So if you understand it yourself and somebody else doesn't, then you can explain it to them and then you can understand it more. I find that independent work can be easy sometimes with like shorter questions, because you know how your own brain works, so you can get what you want down on the paper. But sometimes working as a pair through a question, you can see how you both work things out, and then it's just an easy way of finding different ways to do things, because one person might work completely different to another person, and finding different methods, it helps you understand why things happen.